Everything we thought we knew about the beginning of time might be wrong. For decades, we've had a story for our universe that after the Big Bang, there was a long, dark, quiet period. A dense fog of hydrogen gas filled everything, choking out the light of the very first stars. It was a simple, elegant picture of a gradual dawn. But the James Webb Space Telescope just saw something through that fog. It found a galaxy so old and so bright that according to our timeline, it just shouldn't be there. This light is like an impossible ghost from the past, and this discovery isn't just a new chapter in astronomy. It is forcing us to ask if the entire book on our cosmic origins needs to be thrown out. The cosmic wall. To get why this is so unsettling, we need to go back to the beginning. Not to the Big Bang itself, but to the era right after. The universe was an impossibly hot, dense soup of particles. For about 380,000 years, it was completely opaque. But it also created a new problem. The universe was now filled, wall to wall, with a thick, impenetrable fog of this neutral hydrogen gas. This period is called the Cosmic Dark Ages. It wasn't dark because there was no light. You could have the most powerful searchlight in the world, but its beam would vanish just a few feet in front of you. That was the entire universe. The established story told us that this fog was cleared away gradually in a process called the era of reionization. Our best models, backed by telescopes like Hubble, all pointed to this being a long, drawn-out process that wasn't complete until the universe was nearly 1 billion years old. For the first few 100 million years, that fog should have been a solid wall, blocking our view of the true dawn. No flashlight, no matter how bright, should have been able to punch a hole through it that early. And that is exactly why what the James Webb Space Telescope found is so shocking. The first stars would ignite, and their intense UV radiation would start carving out little bubbles in the fog. Over hundreds of millions of years slowly, painstakingly, these bubbles would grow and merge until the fog was gone. But because any light that did try to shine was immediately swallowed by this atomic blanket, light couldn't travel more than a few steps without being scattered. But as the cosmos expanded and cooled, something amazing happened. Electrons and protons could finally team up to form the first atoms, mostly neutral hydrogen. This moment, called recombination, made the universe transparent for the first time, and it released that famous flash of light we now see as the cosmic microwave background. Imagine you're in the densest fog you've ever seen. The key word there is slowly. The impossible flashlight. Enter the James Webb Space Telescope. Its incredible sensitivity to infrared light was designed to do one thing better than anything before: peer back through time to see the first glimmers of cosmic dawn. As part of its Advanced Deep Extragalactic Survey, or JADES, it stared at a tiny patch of sky, collecting light that had been traveling for over 13 billion years. A galaxy named JWST 1320. The name is a catalog number, but its meaning is epic. The Z13 refers to its redshift, telling us we're seeing this galaxy as it was just 320 million years after the Big Bang. This alone was a huge discovery, making it one of the oldest galaxies ever confirmed. But the real bombshell came when astronomers looked at the kind of light coming from it, and in that data, it found a faint, reddish smudge. Using a special instrument, they broke the galaxy's light down into a rainbow, a spectrum. And there, shining with undeniable clarity, was the signature of hydrogen called the Lyman alpha emission line. This is the telltale sign of hot, young, new stars. It wasn't just a tiny pocket. It was a huge, clear sphere punched directly through the cosmic fog. This galaxy wasn't just a candle in the dark. It was a powerful flashlight that had somehow burned away the fog long before anyone thought possible. But here is the catch. It is also a type of light that is notoriously easy to absorb by that neutral hydrogen fog. It should have been the very first thing to get extinguished. Seeing it at all from this distance is surprising. Seeing it this brightly is, according to the old models, impossible. This wasn't a faint glimmer. This galaxy's light was so powerful, it must have already cleared out a massive bubble of transparent space around itself. The timeline shatters. This is where one discovery snowballs into a full-blown crisis for cosmology. That single line of light from JWST SC 1320 directly contradicts the timeline of reionization. It was fast, powerful, and started much, much earlier than our models predicted. Now, if it were just one weird galaxy, you could maybe dismiss it as a cosmic fluke, but it's not. Everywhere Webb looks into the deep universe, it finds things that shouldn't be there. It's finding galaxies that are far more massive and mature than they have any right to be. It is spotting supermassive black holes in these infant galaxies that are disproportionately large compared to what we see in the universe today. The early universe, which we thought was simple and quiet, it's like it's the same universe again, just younger. This pile of uncomfortable discoveries has led some scientists to say we have a photon budget crisis. The standard model of cosmology, called lambda CDM, is being seriously challenged. It just can't seem to account for this much activity this early in cosmic history. The modeled OS and T have enough light in its budget to pay for the rapid clearing that Webb's observations imply. The timeline isn't just bent, it feels broken. That's a huge puzzle, because our theories for how black holes grow need more time than the universe had even existed at that point. The old story is falling apart, but what new story will take its place? Astronomers are scrambling to figure out what's responsible. If you want to follow this revolution in cosmology as it happens, be sure to subscribe. We're living through a moment where the story of our universe is being rewritten, and you won't want to miss what comes next. It's like looking into the world as first nursery and finding fully grown adults in complex cities. And this is where the story goes from a simple discovery to a cosmic detective case. The prime suspects. So, if the slow burn story is wrong, what's the right one? What could possibly have enough power to blast through the universe's primordial fog so quickly? Astronomers have two prime suspects. Suspect number 1, the Titans. These are the mythical first-generation stars, known as population 3 stars, forged from only the pure hydrogen and helium of the Big Bang. Theory says they would have been monsters hundreds of times the mass of our sun. Because they were so massive, they would have burned incredibly hot and lived fast, violent lives before exploding. But by the gravitational monsters at the center of galaxies, supermassive black holes. When a black hole actively feeds on gas, it creates an active galactic nucleus, or a GN, which can unleash enough energy to outshine all the stars in the galaxy. An early, powerful AGN could have easily ionized a massive bubble in space, but this just trades one mystery for another. As we've seen, JWST is finding black holes that are way too big, way too early. The standard model says they grow slowly, over billions of years. So how did these behemoths get so big in just a few 100 million? This has forced scientists to explore wilder ideas, like a massive cloud of gas collapsing directly into a giant black hole, skipping the star phase entirely. These titans would have been UV radiation cannons, pumping out torrents of high-energy light that could rip the fog apart with brutal efficiency. For years, they were just a theory. But recently, some scientists believe JWST may have found their fingerprints near another ancient galaxy, GNZ11. They detected a cloud of superheated helium with a strange absence of heavier elements. While it's still debated, the most likely culprit for heating that gas is a hidden cluster of population 3 stars. The Titans might not be a theory anymore. Suspect number 2, the behemoths. The other possibility is that the job was done not by stars. The real answer, a cosmic uprising. While the Titans and behemoths are compelling, a third, even more profound theory is emerging. What if the clearing of the cosmic fog wasn't the work of a few powerful individuals? What if it was a popular uprising? We're not talking about majestic spirals like our own, but small, messy, intensely active star-forming regions. By themselves, each of these dwarf galaxies is pretty insignificant. But there were so many of them, and an analysis of their light revealed a crucial secret. These small galaxies were hyper-efficient at producing the exact kind of UV light needed to clear the fog. Recent JWST surveys have revealed something astonishing. The early universe was swarming with tiny dwarf galaxies. As one scientist put it, these small galaxies punch well above their weight. They were churning out new stars like crazy, and they didn't have much dust to trap their own light. This allowed a huge percentage of their UV radiation to escape and attack the surrounding fog. The fog wasn't burned away by a few giant flamethrowers. It was cleared by a billion tiny lighters, all flicking on at once, all across the cosmos. This galaxy-driven model solves the key problems. It explains how reionization could happen so quickly on such a grand scale. It wasn't one bubble expanding, but millions of bubbles all growing and merging at the same time, transforming the entire universe in a cosmic blink of an eye. The impossible light from JWST SE130 wasn't an anomaly. It was a scout from a vast army that was reshaping reality itself. This paints a new, dramatic picture of the cosmic dawn. The James Webb Space Telescope has taken our simple, peaceful story of the cosmic dawn and torn it to shreds. The old picture of a slow awakening over a billion years is gone. In its place is a vision of a violent, rapid, and revolutionary transformation. The universe didn't gently wake up. It was shocked into existence by the furious light of countless infant galaxies. Webb hasn't just given us answers, it has given us better, more profound questions. We thought we knew the story of where we came from, but now we have to ask, if we were so wrong about the very beginning, what other truths about our universe are just waiting to be shattered? The discovery of JWST 130 and its impossible light was the thread that, once pulled, started to unravel our entire cosmic timeline. We were now faced with a universe that was building complex structures and giant black holes, when it should have just been learning to crawl. It's the same universe again, but its childhood was far more dramatic than we ever imagined. This forces us to confront a humbling and exhilarating truth. We are just at the beginning of this new chapter.